The basic idea behind variance and the standard deviation, which is related to variance, is a measure of spread that uses all of the data. Here we're going to consider that we have 5 data points making up our data set. The mean of these 5 pieces of data is here. If we call the data from left to right x1, x2, x3, x4 and x5, we're going to be interested in the distance between each piece of data and the mean. This distance would be x5 minus mu. This distance would be x4 minus mu. Both of these calculations would yield positive results since both of these data points are to the right of the mean. It's therefore reasonable to assume that both x4 and x5 are larger numbers than the mean, and therefore x5 minus mu and x4 minus mu will both be positive numbers. Continuing with the other data points, this distance would be x3 minus mu. This would be x2 minus mu. This would be x1 minus mu. And all of these would give us negative results since the points are to the left of the mean. If they're to the left of the mean, x1, x2 and x3 are smaller numbers than the mean, and therefore x3 minus mu, x2 minus mu and x1 minus mu will all give us a negative result. Once we have these quantities, we need to look at what the concept is of trying to use all of these data points to measure spread from the mean. The basic idea is that what we want to calculate is the average, and in this context the average used would be the mean, distance of the data points from the mean. The problem with this idea is, of course, that the mean is in the middle of the data. So if we add up all of the xi minus mu's, that means summing x5 minus mu, x4 minus mu, x3 minus mu, x2 minus mu, and x1 minus mu, this sum comes to 0. This arises, of course, because some of the numbers were positive and some of them were negative, and with the mean exactly in the middle, this means that the positives and the negatives cancel each other out. If we can make them all positive, this wouldn't happen. There are 2 possible solutions that we could consider to making all of these measurements positive. The first of these is simply to ignore the signs. For example, we know x1 minus mu is a negative result. Let's suppose it was minus 10. We could just take this measurement to be 10. This function, just ignoring the minus sign, does not have nice mathematical properties. A better solution is to simply square all these values, and then the negatives will become positive. This is the one we use. We're now in a position to discuss the variance. The variance is the average of these squared distances. So we take the distances and we square them. And we want the average of these from mu. In order to do this, in the usual way for working out a mean, we add up all of the various x minus mu's. So here we'll do x5 minus mu squared, added to x4 minus mu squared, and so on. This would give us the sum of the squared distances, and when we work out the mean, we then need to divide by the number of pieces of data we have. This formula gives us the variance, but remember, we've squared everything here. So if the units of the original data was, say, in centimeters, this result will be in centimeters squared. And that's why we have the standard deviation. The standard deviation is the square root of the variance, and therefore has the same units as the original data.